Okay, yesterday we talked about the multiplication rule. That was rule number 1. But today we're going to talk about the division rule, and then we're going to talk about the power rule. So, rule number 2, the division rule. To divide the following examples, first write them in expanded form. Then cancel out the bases in the numerator with the same bases in the denominator. Combine any of the remaining bases and they remain in either the denominator or the numerator. This is best explained through examples. So here we are. Number 1, we have x to the 4th over x to the 3. So what we're going to do here is expand the top and the bottom. X to the 4th is just x times x times x times x. That's our expanded form. And x to the 3rd is x times x times x. Now that we've expanded, we're going to cancel out the bases in the numerator with the same base in the denominator. And all we have is one base, x. So this should be easy. All right, here's our first pair. We just eliminated. Second pair, third pair. There's nothing left in the denominator to eliminate, so all we're left with is x in the numerator. Since everything was canceled in the denominator, there's just a 1 on the bottom. And x divided by 1 is just x. So that's what we have left. X. All right. Now number 2. We have 2a squared over 6a to the 5th power. And we're going to expand this. So this becomes 2 times a squared, which is a times a. That's our expanded form. Over 6 is just 2 times 3. And a to the 5th is a times a times a times a times a. That's our expanded form. All right. And we're going to cancel like bases in the numerator and denominator. There's a 2 in the numerator and denominator, so we'll cancel that out. There are 2 a's in the numerator. We're going to cancel it with 2 a's in the denominator. And what are we left with? Well, nothing in the numerator, so that means there will be a 1. And in the denominator, we have a 3 and then 3 a's, so that's going to be a cubed. And that's what we're left with. 1 over 3a cubed. All right, let's go to number 3. A squared, b cubed, c over a, b to the 4th, c. Feel free to pause the video and try this example. Okay, so the answer here, expanded form would be a times b times b times b times c over a times b times b times b times b times c. And now we're going to cancel out factors in the numerator and denominator. There's an a in the numerator and the denominator. Cancel those out. And there are 3 b's in common in the numerator and denominator, so we're going to cancel those out. And what are we left with? Well, we're left with an a and c in the numerator and b and c in the denominator. So that's our final answer. Now, number 4, you can try this one as well. Pause the video. All right, and we have Negative 7 times x times x times y times y times y. Another way of looking at negative 7 is that it is negative 1 times 7. That's a way of looking at it. All right. And then 28 is 4 times 7 times x times y times z. All right, now we're going to cancel like factors in the numerator and denominator. The 7s are like factors. X, y, and we've canceled all the like factors in the numerator and denominator. So we're left with a negative 1, an x, a y over 4 times z. So negative 1 xy squared over 4z. That's our final answer. Or negative xy squared over 4z. So have you seen the shortcut yet? When dividing expressions with like bases, you subtract the exponents and put the result where the larger exponent is. So for instance, if we wanted to try number 5, right? We know how to expand this, and we will handle the negative 12 over 20 in just a second. But just looking at the x squared and the y, right? We could just subtract. So this would be x squared and minus 1, right? We could do that. And then we could do, there's a y to the 1 minus 2. All right, and this is a result because of our exponents here. 2, and then the x by itself has an exponent of 1. The y by itself has an exponent of 1. And so if we were to simplify this, it would become x and then y to the negative 1. All right, we'll talk about y to the negative 1 in a bit. But let's now simplify our negative 12 over 20. So that's negative 1 times 3 times 4 over negative 1 times 4 times 5. All right, so that's just us simplifying negative 12 and negative 20. All right, we just broke those down. And we're going to eliminate like factors. So negative 1s can cancel. The 4s can cancel. And we're left with 3 over 5. So let's combine our number simplification with our letters. So we have 3 over 5 x y to the negative 1. Now this y to the negative 1, we haven't really talked about it yet, but we can just move this to the denominator. Whenever we have a negative exponent, we're going to move it to the denominator. So another way of writing this would be 3x over 5y. Whenever we have a negative exponent, if it's in the numerator, we put it in the denominator. And if it's in the denominator, we put it in the numerator in order to make that exponent positive. So here's our final answer right here. All right, I want you to try 6 and 7